Very welcome again. We're really using him to the maximum. He's given 3 lectures in 2 days and lots of press, etc. So we are so proud to have Charles Hall with us here. Yes, we are. He spent all his life working on energy, initially doing energy related to fisheries, so he's an ecologist, and then he's studied energy for society and its role for the economy, and it's the latter that we are mostly interested in, and especially today. Yesterday we talked about peak oil and its implications for the economy, together with also Kjell Aleklet, and today at lunchtime he gave a presentation at the Royal Academy of Science on efficiency and productivity, and how we need to maybe create a more multidimensional way of measuring efficiency. So, and tonight we're going to talk about biophysical economy and economics, and you'll explain to us what that is, and it's apparently not the same as ecological economics. No. But there's a bit of confusion. Just...
it will cost you another coffee.
I'll get you another coffee. So, we're all a bit tired. Should I say anything else? This is part of the seminar series, but I think you all know that by now. It's this seminar series is about key issues for a transition to a green economy. And many of you have been following this, and energy is certainly a key issue for this transition. And today it will be even more apparent, I guess, after this lecture. Do you have a microphone on you? Or do you need this one?
I have this.
He's all set. Perfect. So, Charles, the floor is yours.
For those of you who've been to others of my talk, then I admire your tolerance. And for those of you who have not been, I will summarize what I said before in about 1 sentence, which is we face almost everything we do in economics is about energy. And if you get toilet trained to think about economics from the perspective of energy, you don't think in terms of dollars, I guess you think in terms of crowns. These are just a means of access to energy. That if you spend $1 in the US and you buy a bagel, then that bagel you need to use about, I don't know where my coffee cup went, of a coffee cup's worth of oil has to be taken out of the ground to make the fertilizer and ship it to Nebraska and to spread it on the field with the tractor, and plus the seeds, and to harvest it and all this sort of thing. So economies for me, either natural economies, thank you, or human-dominated economies are basically about energy. And this morning, in some cases, I took many common things and talked about how I think of them in terms of energy, and in both biologically, forest, fish, whatever, and in society. The other thing I said is that we're very dependent on energy, and there is lots and lots of energy left in the world, and those who say there's lots of oil are correct. But they're incorrect in this way, that the energy that's left is not of such high quality, because humans use the best stuff first, have used the best stuff first, that we think technology can be important. Many people emphasize technology, but in the situation of energy, technology is in a race with depletion, and depletion appears to be winning because the quantity of energy we're able to find, of high quality energy like good oil, we're able to find and is declining, as is the what I call energy return on investment, how many barrels of oil you get back for a barrel that you spend looking for that oil. So that's a summary of what I've said so far, and now we go on further. And I'll proceed this. I think I said a little bit about this afternoon, but I'll say it more clearly here. I was trained as a natural scientist. I was trained in physics and chemistry. I had some very good teachers in ecology, biology, hydrology, in meteorology and geology, all that stuff. And I'm a teacher, and I sometimes teach freshmen. And if I got proposed to me neoclassical economics, the kind of economics that mostly we do, from one of my freshmen or my seniors even, I would give them an A for clever thought and an F for reality. And that's one of the things I wish to say here, that if you're trained as I am in the natural sciences, there's no way you can call what we call economics today a science. We'd like it to be some kind of a science, a social science, or preferably a biophysical science. But for me, as a natural scientist, I cannot accept it as science. And we'll discuss why. So I push this, she says, and so I want to replace the economics that we use, which we call sometimes neo-welfare economics, which has nothing to do with the well-being of, Swedish welfare or something. It's what they call it, and but mostly neoclassical economics, and there's some other sorts of things. And this was originally presented in an economics conference, and we can talk about that. And a lot of this is derived with my colleague Kent Klitgaard, who is a really good economist. And the reason he's a really good economist is he's an economic historian. And as an economic historian, he's not had the blinders put on by being trained in only one kind of economics. The history of economics is rich. And I hope we can talk about that. And I'll just go until somebody tells me to stop. And this is a bit of an old talk with a few updated slides. So I'm mostly interested in what we should be teaching our young people in economics courses. And we teach 1 million people a year in the United States conventional economics, which I consider to be fairy tales. And is the world a different place now than in past decades? We think so. Should we be adopting to this? Does our current generation of economics textbook reflect these necessary adaptations? And we think no. And to make it very simple, I went to a lecture at we have now biophysical economics meetings. Most recent one was just a week ago at University of Vermont. And one of their professors who was a historian, talked about thermodynamics, and he said the development of thermodynamics and the understanding of thermodynamics completely transformed chemistry. Then it transformed physics. And of course, we think about it a lot in biology. I'm a biologist, I suppose. And then it transformed all of the sciences except one, which is economics. And it has made no effect whatsoever on economics. Some facts. Economies of the United States and the world run basically on oil, gas, and coal. People say we live in an information age or a post-industrial age, and that's not true. Just look out the window. Look anywhere. And if you know how to look beyond that, as we talked about at lunch, it's everywhere you look. If you're trained to look in the forest or on the table of food or wherever, it's all about energy. And you know that we use 2/3 of the energy we use in the United States and the world comes from petroleum. It's a liquid and gaseous petroleum together. That's about the same percentage it was in 1970 before we had the first energy shocks in the United States. Production of oil in the United States peaked in 1970. Today we produce only 40% of what we did in 1970. Actually, it's gone up to about 50%. I had a little uptick, and I talked about that yesterday. Consequently, the world and the U.S. became increasingly dependent upon petroleum. And here's what we do in the U.S., in Sweden. It does something like that, but you're a smaller country, at least in terms of people. Well, I suppose in size too. So that's where the energy, but you know, looking at the United States and Europe, the United States imports 1/3 of its energy and Europe imports 2/3 of your energy. Sweden's lucky they have mountains and hydropower, but I'd put my money on the US rather than Europe. From that perspective. Now, this is 1998. We talked a lot about peak oil and so forth. I learned a lot about that. I have no children because I read M. King Hubbard in 1969. And I said, oh, I don't want my children to have to live through this. And he predicted that we'd have a peak in 1990. You know, we didn't. And what he made his prediction, well, just to show you, this is world oil use, you know, and this is when I'm born. So we're looking at one human lifetime, and I'm not even dead yet. So we were growing exponentially and then steep linearly and then less in the world. And I have a little pencil in. So the only thing that means that we're driving cars now, or as much as we are, is that we had the oil crisis of the 70s. Because had we continued this, we would certainly have peaked by now quite severely. And you know, there's discussion, are we at the peak or pre-peak or post-peak, and we're about the peak. Exactly what we can discuss if you want. We know we're going to peak for this very simple fact. This is our rate of finding oil in the past, 1930, 1950. And this is the rate at which we use it. And this much calculus, I think anybody can understand. The integral of this curve cannot be greater than the integral of this curve. And we know that we're using somewhere around, I think this is data up to about here, we are using between 2 and 4 times more oil than we're finding. So we know that cannot continue. We know we're just draining these big oil fields, and Shell talked yesterday about how much of the oil we use comes from very large fields, and we're not finding any very large fields. The last one we found was in UK and Norway, the North Sea. That's natural gas. We talk about natural gas, and a lot of people in the US are very excited, as they should be, because we're having a tremendous increase of natural gas because of this new technology of horizontal drilling and fracking. And it does make a difference. Most of this comes from what's called coal bed methane, but something like this. But the other side of the equation that you have to look at is the green line is conventional natural gas, which is dropping like a stone as we exhaust our conventional natural gas resources. Gulf of Mexico, offshore, that was a new technology, but that's going through its own Hubbard curve. And so when you add all of these up together, you do get our production that's maintaining about the same. We import a little bit, well, a significant amount from Canada and from other places. So I don't know whether the future is going to be this line precisely or even approximately. I don't know why it wouldn't be. But on the other hand, back here, we didn't know about this. So we can't say anything with certainty with gas. I think we can with oil. Yes?
What would you say about...
If you're going to ask questions.
Hi, I'm Magnus from WWF. What would you say about Shell saying that we can provide the world with gas 250 years more, and the IEA then also pointing to the provision of gas being really sort of outcrowding a lot of other energy sources, and so they have a much more positive view of this scenario that the gas will be around for a couple of hundred years more.
I just want to comment on your use of the word positive. I'd like to say something about what's worse than running out of oil. I think not running out of oil. Speaking as an environmentalist, as an ecologist, you can think about that some. I think they're out to lunch. All right, now you have to, if they show me where they're going to get this gas. Now this horizontal drilling, I explained this morning how you have these big maps in the US with these very large areas of new gas fields, but they're not. You only get now significant amount. I focused on oil from these areas, the same for gas, but we have less data. From the oil, and incidentally, our best gas fields like that were going to save us all, like Barnett in Haynesville, have already peaked and are going down. So it's hard to say. So I spoke. Shell told me yesterday that you're not going to be doing the fracking in Europe that we're doing in the U.S. because the quality of the resources are not that good. But in the U.S., what we do is we paint on the map these very enormous fields, but almost all of what we get comes out of sweet spots. So first of all, I'm going to say they might be right. Second, I'm going to say, well, I don't see how. And third, I'm going to say is what I talked about earlier, is this best first principle, or Ricardo's principle if you're an economist, that the oil companies are not stupid. They know a lot about the earth, and they go to the best places first. And at some point, when it costs a barrel of oil to get a barrel of oil, we're approaching. Another decade or two if you extrapolate today's lines, or for gas, a cubic meter to get a cubic meter. At that point, it's no longer a resource. It doesn't matter how much is in the ground. And I said also that it appears that the depletion is trumping technology. So we don't know what technologies will do. We certainly have marvelous new technologies in oil, but it doesn't stop EROI from continuing down. And I guess the third thing I want to say is, as a scientist, I don't know. But I know that governments are not funding young university people to analyze these things in the way that I talk about, or other ways that might be useful. And consequently, we don't know. So most of the work that I do is not funded by governments. One exception with the United Kingdom, not US, but has funded my EROI research. This is a good question, a very good question. Would anybody like to follow up a little bit on this, or are we okay for now? Okay for now. So let's get on to economics. We're not alone. Recent Nobel Prize winners in economics, Sen and Kahneman and Stiglitz and Ackerman, have basically all got their Nobel prizes for undermining conventional economics. I don't think they go 5 or 10% as far as you need to go, but that's it's going that way. Now, what is how many economists in this room? A lot. How many conventional economists in this room? Good. And I would really like you to ask me some difficult questions, please. Okay? Or the rest of you. So, is this okay? Economics is the study of the allocation of scarce resources amongst competing ends. Is that okay for you? That's good? Yeah. So, here's scarce resources. Apparently, for an economist, is the money in your pocket. And resources. This is what resources means. And it doesn't mean what I think of resources of water and fish and oil and whatever. So just make sure you understand that. I mean, it's perfectly good use, I suppose, of the word resources, but if they said money in your wallet, I would be happier. How do you want to allocate the money in your wallet, which is a scarce resource for most of us, among competing ends? And so here's a standard view of inputs and outputs of the U.S. economy, which I happened to do for a different project in 1990. In 1990, we did an analysis called the Environmental Analysis of Having a Baby in the United States. And we wanted to know how much resources a new American citizen would use in their lifetime, which we thought would be what having a baby meant. And so that's not this data, but it's where I'm going to go with this. That's why we did 1990. I haven't redone this. So the capital, that question mark shouldn't be there. About 5,000. This is the input, is capital and labor. And so for one person for 1 year, this is approximately the input and the output. And here's the input, and here is the output is GDP, about $20,000. And that's how it's viewed. You correct me anytime you want. Okay, and this is a social definition of economics. It implies that scarcity is only relative scarcity, that humans are rational. We can discuss that if you want, that firms, households, and markets are all that you need to make a legitimate economic analysis or understanding. We all know that's not true. An equally legitimate view of the U.S. economy is this, that these are the inputs that you need, 2,500 kilograms of oil and so forth, and all this water and rock and iron and cement. And the outputs are not just GDP, but all of these various pollutants. That's what our economy does for one person for 1 year. This is a very incomplete view of what an economy is. And so this is what you find in chapter 1 of, as far as I can tell, every economic textbook. It's an economic systems of linkages between households and firms, and is that. And the arrows go around with money, and the firms pay households money, and the households provide firms with land, labor, and capital. And this cycle thing goes around and around. Now we know that at a minimum this system must, we as scientists, not necessarily economists, must live within ecological and physical systems, and you have to have inputs and outputs in the real world, that this cannot break the laws of conservation of energy and mass. And I think there's some words that just don't show up in here, but anyway, you get the idea. And we want to go beyond that. And so a second definition of economics is from Polanyi, I think it's spelled wrong there, who provided what he termed a substantive definition of economics. Economics is a study of how people transform nature to meet their needs. That works for me, works for, I think, people around the world, because that's what we do. We take nature and we apply energy, and you generate what we call goods and services. There's no goods or services that I know that don't happened that way. And what we tend to do is to look at what I've done is to just get some idea of what these exploitations of resources might be. I used to live in Montana. I'm moving back to Montana. And this is what K. Ross Toole, the great historian of Montana, he says Montana is about booms and busts. And that these are the booms. Beaver was, at least for the European Americans, the Native Americans had their own quasi-sustainable system before that. And beaver, then gold, silver, eastern dryland farming, then the soil blew away, and that was it. And then copper was the big one for Montana, and timber, and now agriculture has been kind of flat for a while, but is maybe going down, and it's running like a lot of places, kind of on tourism, and I'm not sure what. And we've done this for Ecuador. This is from data from the United Nations, and I never got a student to properly do this, but basically it's going through whatever you can get. The big one lately was shrimp from these are native shrimp, and this is, this purple one here is from, would they go in and destroy the mangroves and make shrimp ponds, and then white spot disease moves in and the whole thing is busted and left people with big losses of capital and so forth. And then Ecuador is going on, is going on oil production, which we guess will peak around pretty soon. And we don't know what's next because oil consumption is going up. And this is the case for all oil exporting countries like Ecuador, as the internal consumption is going up as there's more and more people and more expectations of affluence and more pushing people together into cities and so forth. So for me, economics is summarized as this: for every dollar you spend, well, we went through this too, you spend is somewhere in the world about this much oil. So a dollar is 7 crowns. So kroner. So every 7 kroner you spend something like this much oil, maybe a little more, or its equivalent as gas or coal, has to be taken out of the earth and used to generate a dollar's worth of good or service. If you buy a bagel, did I say this? Yeah, I said this, didn't I? So what is wealth? Now, you know, there's production and there's wealth. Wealth is some kind of stock, not flow. And money is our usual measure of wealth, but we all know that money is notoriously slippery. You can print more money, which we seem to be doing astonishingly in the US now. We don't do it like this anymore. We do it with the Federal Reserve. And we don't get inflation because the rest of you think that dollars are valuable. And so I do believe in supply and demand, and so there's a demand for dollars that keeps its value up. So, but a lot of people think we should use a harder measure, usually gold. And so if you go through the churches, this is Siena, but you can go anywhere in Europe, probably in Sweden, I don't know about Sweden, and find all this gold. But when the Spaniards came back from the old world, from the new world to the old world with gold, extracted an enormous human cost and environmental cost. They doubled the amount of gold in Europe, but they halved its value. It's like printing more money. So gold is not an absolute standard of value. It's a medium of exchange because the wealth, oh, there it is. The wealth came from the sun, the rain, the wind, the natural energy flows, and from the activity of foresters, fishermen, farmers, housewives, artisans, etc., who did the physical work to generate the wealth. And then we could use gold as a means of keeping track of it. And then there's some beautiful old work done on the denarius of Rome and how over time, this was adulterated with copper. The silver was adulterated with copper, and how that led to inflation. So it's a very old story. And you can look at the crustal abundance of different metals, and this is the energy cost of getting them. So gold is in a certain sense a good standard because it's hard to get, because you have to use a lot of energy to get gold. You have to grind up a lot of the earth to get gold, so that keeps you from printing your money too fast. And that's why gold is perhaps some kind of standard of value that's more solid than money. Well, there we go. There you go. Expensive things are usually energy intensive, including your dinner. Now, in the classical worldview, wealth comes from the activity of labor. The physiocrats before that, if any of you know, the physiocrats was the first economic school in France, especially Quenet and others, and they felt that wealth came from land. This was in 1650, 1700, and the classical guys, Adam Smith and Ricardo and Marx, thought it came from labor. And then the neoclassical, that's contemporary economics, following the marginal revolution of the 1870s, 1880, they felt that wealth came from capital. But each of these is actually referring to the energy of their times, because in 1700, 1750, land captured the energy that was used by humans by intercepting solar radiation. And so if you were wealthy in old England, and I'm sure old Sweden, you owned a lot of land and you intercepted a lot of sunlight. And in this thing you have the handout there on your right, page 8 is a marvelous story from a Swede, Ulf Sundberg, a friend of mine in the old days, he's dead now, Forester, about the energy return on investment of Swedish foresters back in 400 years ago. It was marvelous. He's looking at the time when land and labor and solar interception were important. When Adam Smith was at a time when labor was concentrated in factories and became very powerful in forming new stuff. And then Solo says wealth comes from capital, but meaning capital money and capital equipment. But capital equipment, at least, is just a means of using fossil fuel. And that's why, so each of those you see is energy. And you could have a much more unified view of economic history by looking at all of it as energy of the time and how people understood it at the times. Because, you know, Ricardo, especially, I love Ricardo, he was a very smart guy. And but they didn't know of thermodynamics then. They didn't really have it figured out till around 1870, 1880. Too late to help Stanley Jevons, but with generating neoclassical economics. And most labor, you see, is not so important because this is, for the United States, is fuel, is the energy we use now, not muscles.
Where did that picture come from?
That I came from one of my old books.
It's your picture?
Yes. Now, I'm sure I stole it from somewhere, but it's easy enough to generate. But we have a book that some people now, including myself, call the Energy Bible that we published with Cleveland and Kaufman in 1986. That's got a lot of, that's where we worked. I worked out all this stuff originally with Kaufman and Cleveland. So, and I'll tell you a story about them too when we get to labor productivity. Neoclassical, so I just said, there you go. And so there's that model, and but it isn't that. This doesn't have the input. So I guess I summarize this a little bit. So, well, I'll summarize it right now. We wrote a paper with some of my German colleagues called "The Need to Reintegrate the Natural Scientists with Economics." We published it in Bioscience. This is a pretty good American journal in 2001. And we said, we as physicists and natural scientists cannot accept economics because this model, it breaks the laws of thermodynamics. It's a perpetual motion machine, and we know we can't have that. And the boundaries are wrong, and we'll talk about that more in a moment. And the basic approaches are put forth as givens, not as hypotheses to be tested. So even when I remember taking my introductory biology course, I'm a sophomore, and you know, they said, well, these are hypotheses, this is how you test hypotheses, and so forth and so on. Another issue in economics are Cobb-Douglas or similar production functions. And if you took a physicist or any natural scientist and you said, well, how do you make something, a table or a computer or whatever? And they'd scratch their head and they'd think, and they'd say, well, to make it, you know, you'd start with some stuff, and then you'd apply some energy and some design, and you bang on it and hammer it and get it the way you want it, and there you have what you want. This is missing from here. You just have capital and labor. You don't have the energy that is required for the transformation or the raw, or the earth as a source of whatever is needed. Where am I going with this? I'm going to the necessity of having a biophysical economics that we may want to have some aspects of social science in what we do, but social science alone, which is where it is today, is insufficient to serve as a basis of economics. I would not accept it from one of my undergraduates. I would turn the paper back, perhaps, as I said, with some kind of good grade for cleverness and a very poor grade for connection with reality, because I require that of my freshmen. Let's take a look at this. If you start these Cobb-Douglas production functions, and a guy named Dennison particularly, and there's others who've worked on this, if you use this and you look at the increase of wealth, then the wealth over time increases this much, and the capital and labor increase only this much. And there's a residual of about 50%. Statistical residual mean unexplained. And why is that? Well, there's no energy in the equation. Now the economists like to attribute this residual to innovation. Karl Goran Mahler said to me, oh, but it's this spark of human creativity. But in fact, working with Rainer Kummel, my colleague on this, if we look at Japan, when we put energy in these production functions, the residual disappears. And energy is more powerful than either capital or labor in explaining what happens and the increase over time. Now, talked a little bit this morning about whether the United States is cooking the books in, that might be the reason for the discrepancy, might not. Well, there you go. This is what I just told you. And what's the difference between accepting neoclassical economics and going to church and accepting religion? So somebody can answer that for me, perhaps. So there you go. You can read that. So we need this new approach, I feel. And I'm speaking to you as a natural scientist. And I think it's embarrassing for me to look at conventional economics. it would be destroyed in any natural science department. And why has this happened? Now, we can get into other social sciences problems, of which I give just a few examples of many dozens that we could do with conventional neoclassical economics. And people are supposed to be rational. Rational means that you make decisions based on what's valuable to you, what you perceive as valuable, and you make the decision, and it's kind of a shorthand for saying that people will make the decisions that provide them the best monetary relation. And so all kinds of people, Heinrich has studied all of these. There's a guy at Harvard that's done this really incredible stuff. Come up, I'm having a senior moment here, but anyway, and he finds that when you do this experimentally, in other words, when you test the economic hypotheses, that people are far more likely to be altruistic or vindictive than to be rational. They will give up money, significant amounts of money, to punish people who break the social norm. Beautiful experiments. We just said, I don't know where that came from, but we've seen that. Now, this is how real economies work. This is, I want to replace that firms and households with the minimum model that I would accept as how real economies work. Okay? So you must start with the energy sources, because without energy nothing happens, including economic production or even economic exchange. And so here's the energy sources for the Earth, the sun, the geophysical, and the nuclear, and then these intersect with the materials of the surface of the sun and generate the water cycle. Is probably the proper functioning of the water cycle is the most important component of the economics in the world, but it's not included in the economic assessments because it doesn't enter into markets. There's no price put on it. And then all the processing of natural systems, and for those who can stomach the matter, those who like the matter, ecosystem services and so forth. And then this is energy and matter in the past have been deposited into fossil fuels. And then minerals have concentrated by all these global geological and often biological processes and so forth. And in this, you see the energy and matter travel together throughout what we're going to do here. And then we come into cultural transformation. And the cultural transformation, cultural simply means pertaining to what humans do. So the first step is exploitation, and this is Polanyi. And so we exploit this energy and these materials by clearing the land and putting our grazing animals on there or damming the rivers or putting the oil wells down. I want to come back to this for a second. I had a Native American friend, Ogala Sioux, who I spent some time talking about. I was raised an Episcopalian, but it didn't take, and I've been pretty close to an atheist, but I like very much how he explained it. He said, well, he talked about the Great Spirit and how the Great Spirit is everywhere and part of everything, and that we Native folks, perceive the sun as the father and the earth as the mother, and their interaction as what generates all value. They wouldn't use the word value, but all life, all things that allow us to live on this planet. And as an ecologist, I found I really liked that. And that served as a good religious basis for me, or spiritual basis for me, that it's the interaction of the sun and the materials of the earth that generate the Great Spirit. And generate all that's important. And anyway, so I am offended when we have to put a dollar value on it, you see. But humans, this is what humans do, and me too. They exploit it. They process it, a butcher block, a sawmill, a petroleum refinery, a power plant, a steel mill, manufacture food, fiber, factories to make all kinds of stuff. And you know, in all of these, you see the energy and the materials are flowing through this whole system and are cycled back to allow these things to keep happening. And then there's consumption, and in a certain sense, market economics is just dealing with, you know, this. And this is what's required. And then, and the heat's given off at every step with a second law of thermodynamics, and eventually most of the stuff ends up in the junk piles, and some of this is recycled, and there you have it. So that's the minimum diagram that I think should be in every basic economics textbook. That's how you should learn economics, not that stupid firms and household diagram. Okay, energy and economic production. This is when we first did this, the use of energy and GNP increased almost the same. You plot one versus the other. It's a straight line with an R squared of 0.99 something. And I talked about that this morning, so I won't talk about it anymore now unless somebody wants to. You look as countries develop. Korea was very successful. This is a bit old, but as Korea developed, its GDP per capita increased, but its energy use per capita increased. Likewise, Mexico, even the Netherlands, the USA is more complicated, and I don't want to talk about it unless you ask me to. Costa Rica didn't increase at all because the population rate increased more rapidly than or as rapidly as did the energy use. So yeah, we have all of these theories of development. You can find any Domar's theory of development, and except he didn't come up. Somebody used his name. He didn't like it, and I can't remember the other theories of development. Here's Hall's theory of development. If your energy increases more rapidly than your population, you get richer. If your population increases more rapidly than your energy, then you get poorer. And if they're the same, you stay the same, like Costa Rica. Costa Rica does a lot with the energy that it has, that it gets, that it uses. So there's all kinds of social mechanisms of efficiency and so forth. There you go. I challenge any economist to refute this statement. With me. Now, a lot of people think these things have been negated. These studies have negated the importance of resources. Barnett and Morse, you know about Barnett and Morse, and they found that prices of raw materials corrected for inflation, except for forest products, did not increase over a long period of time. And Paul Ehrlich made this made this bet with an economist, Julian Simon, who believed that human ingenuity was all you needed, and limits to growth. Limits to growth. There's some limits to growth. Club of Rome and all of that. How many of you heard of limits to growth? Most of you. How many of you think that the model has failed? Nobody. Okay, so does that mean you all have read our Hall and Day, 2009, or Graham Turner? Anyway, the model is 40 years later. It's right on the money. No model of economics that I know is that accurate. I had dinner with Dennis Meadows last week, and well, there you have it. So Cleveland found out the reason Burnett and Morse, the reason that the price of raw materials didn't increase was we used more energy to extract them, and energy was getting cheaper during the period they did their analysis. If you look at the price of raw materials now, it's rather increasing. And Ehrlich, well, you know, we've done all these things. And one of the problems, they didn't have the technology at the time to put the numbers on the axis, so everybody thought this stuff was supposed to happen. Well, you know, we're only here now. We don't know whether it's going to happen. The model, oh, the economists hated this, attacked it fiercely. So you all know these things. So. What else we want to talk about? The markets solve the problem. Does the market solve any problems? We could discuss that. Well, you know, our presidential debates, thank God Obama won. Our presidential debates, not that I don't have some problems with Obama, but we're all about, let's think about it. What they're about is how can we deplete the world's oil resources faster? That's because they're about growth. Let's grow our economy. To me, that means let's deplete the oil faster. And the Economist has trumped science in the media and in many people's minds. Probably not the minds of some folks, maybe most folks in this room. And there you have it. But I mean, even so, you know, I understand you guys are doing this ecosystem service valuation and stuff. Yeah, I mean, what you're doing is you're just becoming part of the problem, in my view, because you are allowing conventional economics to set the standards. That we should evaluate nature in terms of money. I think you should evaluate your spouse in terms of money, your children in terms of spouse, your grandmothers in terms of money. It's, to me, just an inappropriate metric. And what's part of the whole process by which neoclassical economics has won the debate, and we're just following that, and conventional ecological economics, at least most of what's done and so forth, is just following right along. And one of the reasons that myself and Klitgaard just wanted to develop biophysical economics was to get out of that trap. We have some other problems. We can talk about that. Oh yes. But, well, okay, I just said this. So, you know, so far so good on the model. I don't know where we're going, and we might have some rough sledding coming up in the world. So we'll see. That's just talking about, if you care about this, read our paper in American Scientists. It's, make sure you can download it from my website. Efficiency, oh, we talked about efficiency. Labor. You know, it's kind of interesting. When we were working out these ideas that Cutler, Cleveland, and Robert Kaufman were undergraduates, and I was a young professor at Cornell University, and I got so tired of what I considered to be crappy models in ecology that I turned to economics, thinking that it would be much more rigorous, and that they had better mathematicians, and they had many more of them, and they had Nobel Prizes and all this kind of stuff. And so I thought that I could go into economics and I could find more rigor, not mathematical rigor, because that's irrelevant, but I could find more scientific rigor. And I found, instead of studying economics for 7 years, that it was worse than ecology. The models in economics have almost no validation unless it's circular, and we can talk about that. But it was kind of interesting how, this is just a little story about how it worked. So Kaufman was a screaming leftist Marxist at that time, and Cutler Cleveland was a big hunk of a jock, conservative, you know, those lazy bastards not doing their work, and that's why labor productivity is declining and so forth. And they would argue with each other, but we were all very fond of each other. And so we said, well, you know, let's look at labor. We'd look every week. I got $800 for the dean that allowed me to hire them both for the summer, and that's the reason I'm here talking to you about this. Let's look at, this week I said, let's look at labor productivity. So we do a different economic thing each week. And this was the week of productivity. And so they start off on arguing with each other from a Marxist view and from a, I don't know, neocon view, let's call it, et cetera, et cetera. And I said, well, you know, I think we should think about labor productivity from the perspective of energy used per worker hour. Yeah. And then Kaufman said, I know where we can get labor productivity. And Color said, I know where we can get the energy use in industry done. And they go running off, happy as can be, together to the library. And they come back to me 2 or 3 days later with this graph. And there was no further political discussion of the issue, saying, yes, that's how it happens. And it didn't matter where their previous political orientation, they found it irrelevant, which I think would be the case if we could do more of this. Oh, then there's the Phillips curve, you know, that inflation, this is the curve in the textbook, is inverse to unemployment. So if you're getting too much inflation, and Jimmy Carter did this, so we put people out of work to get rid of inflation. It's actually gone in and impacted people, et cetera. But if you look at, you know, for a while the data was very well behaved, you see? And then the oil crisis came and we went off into orbit. And that's called stagflation. And so, but the economists could not explain this, did not explain this, and have conveniently ignored it and either don't talk about the Phillips curve or come back to this. Whereas, in fact, you can see that energy and the price of energy and the availability of energy is what actually is determining what's going on. There's so much in economics you can tear to pieces if you understand how energy works. Conclusions. Economics remains largely about investing energy and exploiting nature. Real economies, not what we teach. It's this simple. It's this simple. If somebody, you're arguing with somebody and you say, well, what does economics mean to you? Or you? One of your friends. And they'll say, oh, something in the university. Oh, no, not in the university. What does economics mean to you? And after a little while, most people come up, well, it means, you know, food on the table, a roof over the head, Volvo in the driveway, perhaps. That's stuff. It's about stuff. It's about the material world. And you don't study stuff as a social science only. You study it from physics and chemistry and geology and all of these real sciences. I'll say that. Economics is not a real science. It doesn't follow the scientific method. So this is something we want to teach in economics. I'd love to. We're starting to teach this in the high schools. Because in New York State, every student has to take a semester of economics. And so we say, well, let's teach them something real. And so a surprising number of high schools have agreed. So we have all this material available for free, or if you want to make a little contribution to any high school teacher. And we'd like to say, and I have a Swedish high school teacher who'd love to do this, but she applied to whoever the powers that be, where we were this afternoon or something, and oh, you had to have it in by last year, so you won't do it for another 5 years, and so forth. So anyway, I think well, of course, the university, you can't do it with most people who are economists because they don't even talk to you. They don't want to hear it. So here we are. I'm finishing now. This is where most of our economic and financial theories were derived. Of course it would work. Whatever cockamamie, left or right or up or down theory you come up with, you're going to have more oil next year, so you're going to have growth, and it looks like your theory worked, huh? And then here we are. If you hadn't noticed, a lot of our economic and financial theories aren't doing too well now. And we have no economics available for what to do over here. And that's coming. Well, this is my attempt to put all of this with Kent into a book.